Hello everyone, how are you all doing? As this will be the first video of the year, I thought it would be fitting by adding some cool new feature to our game. It's called Painter's Algorithm. And no, it's not Bob Ross as a math teacher.
We don't make mistakes. We have happy accidents.
It does, however, create an illusion of depth, which would be very cool to our 2D game. I would also like to announce that Doomin is back as a member. Welcome back. I appreciate your support. Some cool changes is coming for the membership for this channel. I will make a video about that once I have all the parts needed. I think it's gonna be cool. Now, since the last video uploaded in this series were about a month ago, let's dive in and check how far we've come. Without further ado, let's just start it up and see how it looks. Our objects are looking so-so, but they are working and they are in the game. We have a big frog covering the entrance, even though I can still enter it. And once in here, there's different enemies and no objects, because they are on the outside map. And today's episode, we want to create an illusion where if I'm behind an object, like I am here, then the player should be displayed behind the oven. Because I'm standing on top of it, and that just, doesn't look correct. It just looks wrong. So the idea here is that when the player is behind something, or should be behind something, it should also be rendered behind it. The same goes for if I'm in front of an object. This looks correct, but as soon as I am behind an object, I should not be seen, because the object is covering me. Simple enough, and that should also work with the enemies, with objects, enemies with the player, etc. And that is what we're gonna do today. And it's not that difficult. It's something called Painter's Algorithm, or also known as depth sort algorithm. Sounds fancy, sounds complicated, but it's not. So let's get right into it. The way this algorithm works is that we're gonna have all the objects, everything that needs to be behind or in front of things depending on its position. Tiles, we don't care about that, they are always going to be on the floor, we're never going to be behind a tile. So buildings, player, enemies and objects so far. We might get more projectiles later, whatever, but those are the things that needs to take into account its position and where it's going to be displayed. And we're going to sort them, all the Y position of everything, player, enemy, building, etc. And the one with the lowest Y value in the position is going to be rendered first. And by rendering it like this, it's going to give us an illusion of depth. So if the player is behind something, it has a lower Y value than, for example, the object in the beginning, the statue, then the player is going to get rendered before the object. So the object is going to be rendered on top of the player, hiding the player. And we won't do any crazy algorithm math in this episode. Everything is there for us. All we have to do is to pick all the pieces we need and then just make sure it looks nice. So let's begin. All our enemies, the player and the object, is extending entity. Entity is the superclass of all of them, but for some reason not building. I don't know why I decided that building is not an entity. It's technically is. So our first change is to make sure that building extends entity. I'm also going to change up how I code these videos. So instead of you watching me code it all out, I'm going to show the before to after and explain the difference and why there's a difference. So first off, we're going to extend entity. We're going to get rid of this position. We really don't need it. And that's because in our entity class, we have a hitbox. And if we want to get the position, we just use getHitbox.left and top. So first, we're going to pass in position to our superclass. We got an error. We're going to get to that in a second. And then there is the same. We get rid of this get position call and we use a different one. Get position by new point using the hitbox left and top. I'm keeping this method, just changing it up a little bit, and that's because we need to keep this get position because we're using it somewhere else. So that's just to make sure that it works after a change here. So we can get rid of that and we can get rid of that. And that. So let's go to our entity class and take a look why there's an error. And that's because the entity asks for a position, also width and height, so we can create a hitbox. But our building does not need a hitbox. So what we can do is either give the building a hitbox or we can just work around this just for the building's sake. And we're going to work around it. So in our entity class now, we have a new constructor, a little comment here just for the building or for the building only. We're creating this hitbox that is just to make sure that it still works and that we can get a position from it when we are calling building.getPosition, because it returns a point F from the left and top. So this is going to work, and it now allows us to use entity for all our objects. In our update method in the playing class, we're going to sort our arrays, and we're going to do it in the end. Sort array. Simple enough. And in here, we're going to have an array of all our entities and sort them by their Y value. Simple enough. But how does this work? First, we need an array. I'm using an integer array here just for testing. And to sort this, you call arrays.sort, and you pass in the array that you wish to sort. And of course, we need to import that. So it's going to take an array with numbers here, and it's going to sort them. How will we know if it works? We have an array of numbers that is not in order, 5, 33, 1, etc. Then we sort it, and now we're going to check if it's working. So let's run this. Here was our array. Then we sorted it, and here's the result. 1, 1, 5, 27, 33, and they are all in order. Of course, you can put them in specific order, you can only sort half of it, you can sort from highest to lowest instead, all sorts of fancy stuff. We don't need that, we just need to sort it from the lowest to the highest and then render it according to that result. So this is just a demonstration how it works, but there's a lot more that you can do with it. And the algorithm is in here, and if we just keep going like that, we did not have to figure this out. We don't need to talk about it. It's already taken care of for us. So we just call arrays.sort and sort whatever array we need. We don't have a array with all our entities in playing or anywhere else, but we do have a game map which consists of all the entities we have. Doorway is not an entity that we care about. It's just a place. So we're going to care about the skeleton, objects, and the buildings, and of course the player. We're going to get the player last, but here we need to have a method that returns all entities in one single array. That is called GetDrawablesList, and it's going to create a list of entities, and then we're going to put all our entities in here, and since they are all extending entity, they will all go in this list. And then later, when we're going to draw it, we can check if the entity is a building, skeleton, object, or something else. But we need to store them in the superclass entity. And we have here a simple creation of a list, but we don't know how many entities there are in this game map. So we need to create a method for that called GetDrawablesAmount. And what it does is checks the size of all the arrays and then returns the size. And it also adds 1 for the player. The player is not in game map, but the player needs to go into this list. So that's what this is doing. Checks the amount, adds it up, returns it. So all we call here is GetDrawablesAmount, like so. And of course we need to import our entity. And make sure you import the correct one. We're using the one in our game and not somewhere else. And what it's doing here is iterating through the building array list, adding all of them, then doing the same for skeleton and objects, and then returns it. Simple enough. What we need to do now in our playing is to get that array from the game map into playing. And if we change the map, we're going to get another array. We only need to do that once for maybe when we load the level or when we switch level, wherever. So up here, we're going to store an entity array, list of drawable, and we're going to do the same import there, called list of drawables. In our update method at the very start, we're going to have a build entity list. This method is very simple. It's going to build the entity list we have in this playing class. So we call map manager, get current map, and get the drawable list. This one we just made. But we only need to do this once. So if we enter a map, we need to do this build entity list, and then we're done for the entire game map till we change it to another one. So we just need a simple boolean that says list of entities made equals true, and we're going to store this right under our list of drawables. So we build it, and then we set it to true, and we're done. But let's not forget that we added a place for the player, but we never placed the player in here. So what we do is to say in the end, the size of this, but -1, is where the player goes. So now we have all the entities and the player in an array in the playing. So what we need to go over to do now is to sort it. All we have to do now then is arrays.sort, and we place this array in there, like we had list of drawables. Well, this should work, right? Let's see if it does. And it didn't. Why not? There's no errors here. So what's going on? Let's go to the bottom and see what it says. Skeleton cannot be cast to Java lang comparable. Class cast exception. Never heard of it. The reason why this isn't working is we're calling sort of a list of entities or a list of entity, and Java doesn't know, okay, but what are you trying to sort? This isn't just, this is objects, this is a class with a lot of different things. What are you trying to sort? So we need to specify this. So let's go to our entity class and implement something called comparable and specify that we're comparing an entity or with the entity. And this is actually an abstract class, so we don't get the error that that we should have. But if we go to building, it's going to say implement the method declared abstract or implement abstract method compared to blah 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 blah. We can do this, we don't have to actually type it out. So I'm just going to OK. But we're going to take this because building is extending entity, but we want it in the entity class. But if the entity wasn't a abstract class, let's remove it. We would get this error because Java still expects us to extend entity to be able to use it. So that's why the error didn't show up, is because it's already expecting us to use another class. So it didn't throw that. But we want it in here. Let's see. Override, yes, override compared to entity. Oh, so we're comparing another entity, one entity, this entity, with another entity. This is all taken care of by the sorting algorithm. We just need to do some code here to specify I want you to compare this value with this value. So we can say other. The other entity, return float.compare, because we're going to compare floats. So we're going to compare hitbox.top with other.hitbox.top. So now it's going to compare our hitbox, or this, whatever entity it is, y position, with another position or another entity's y position, and place them accordingly in an array that is sorted. So let's go to our playing now again, and let's see if this works, or if you get any errors. That means we didn't. We sorted it and no errors. Now we just need to use it. So that's next up. Now we're going to draw this sorted array. For us to be able to draw all our entities in an order, we need to draw them one at a time and not all skeletons at a time and then all objects at a time, etc. or in here. We need to draw them one at a time. So let's head over to our map manager, how we draw everything. The tiles we don't really care about, or we do care about, but they're not going to be part of this sorting algorithm. So we're going to skip them for now, drawing the buildings and then drawing the objects. Buildings and objects right here. So here we're drawing all the objects in one array and then moving on to the next one, which is not what we want to do. What we want to do is to draw, as I said, one at a time. So for objects, we're going to just call it draw object, asking for the canvas and the object to draw, and it's a copy paste of this draw method. And the same goes for our building. Using canvas building that we pass in and then draw it. The same as up here. So we can remove this method and then this method. So now we have two new methods that's specifically just drawing the object and drawing the building. We got some error here, and we can remove this method. Let's just check for, yes, it's public. So let's remove that, and head over to our playing. Since draw doesn't exist anymore, we still need to draw the tiles, so just call draw tiles, and we're gonna call draw object and building when we are about to draw a specific building in the order. So we're just gonna keep the tiles at the very bottom. We can comment out draw player. For the skeletons, we are looping through it and then call draw character, which is in playing, I assume. Yes, it is. All right, and of course we can comment that out. The playing UI, it's still gonna be on top of everything. And now we're gonna call a method called draw sorted entities and create that method. And in here, we're gonna loop through this sorted array and then draw them accordingly. We're gonna have a enhanced for loop going through each entity in the list of drawables. And here we have something called instance of. So if we're checking if entity is an instance of skeleton, if that's the case, meaning the entity is a skeleton, then we can draw a skeleton on that entity. But we can't use entity.draw character or whatever. We need to recast it over to a skeleton, and then the skeleton we check here. Let's add a enter here. If the skeleton is active, like we've done before, here somewhere, here, we're checking if it's active, meaning alive, then we draw it. And the same goes for objects and building, and last we're checking if it's a player. If it's a player, we don't need to recast because we already have a method for it. So we simply draw the player then and remove some of that dead space. And of course, if we're attacking, we're also drawing the weapon, so the weapon will be drawn right after the player, regardless of where the player is in this array. And if we hover over here, it says variable skeleton can be replaced with a pattern variable. Okay, let's see what that is. So it's asking for E instance of skeleton, and it's recasting it over to a skeleton right away. So we don't have to have this line, it's already part in the checking. So that saves us some space, and there's a few shortcuts here and there. That's one shortcut. Good to know about. So what's happening here? Looping through it. If it's a skeleton, we draw skeleton. If it's an object, etc. And then we draw the player. Looks good. Let's see if we have a somewhat working array to be drawn. All right. Oh, we saw one there. Yep, the skeleton. Did you see? He was behind and then he was in front. It's kind of working, and I know already that it's not going to work for a player as we want. Going up here. Nope, I'm still above the this object. What about this one then? Oh, I'm behind it. I'm always behind this one. I'm always above this one. What's going on? What's the bug here? Well, we're using the top or Y position for all entities and being sorted, but the player's position never changes. It's always in the middle. We're using camera values to move the visual of objects and entities, but not for the player. So that's something we need to take into account. But otherwise, it's working. So let's see if we can get this player to render correctly as well. What we need to do now in the player, we need to override this entity compare to, how it's comparing, because the top value of player is never changing. We need to add or remove the camera Y. So in our player class, we're going to have a value. Let's make it private or protected. Protected last camera Y value. Then we know exactly what it is. Oh, we need to be a float as well. Like that. We can set it to 0, right? Just so we know. And we'll of course need a setter for it. Set the last camera Y value. Alright, now we can do that. And then we need to take this method, or copy it, go to our player. And since player extends character and character extends entity, if we override the entity method here, we're going to be using this one instead. So I assume we can just go minus last camera Y value. And then if we compare something else, we don't need to care about it. It's just for the player's hitbox. Alright, that sounds good. So let's go to playing and just add that call. Sort arrays. So before calling sort array, we say player dot set last camera value, camera Y, because the camera Y always changes depending on where we are or how we're moving. So let's run this and see the result. Should work better now. It didn't even start. Why is that? Attempt to get length of null array. And that is because when we render, it tries to render before there's an update. So let's simply add a check here. If list of entities made, if it's made, then we draw it. If it's not made, then we don't draw it. So one frame, we might not draw any enemies, but as soon as this list of entities are made, we then have a list to be drawn. That's just something we need to make sure doesn't break the game. Let's run it again and see how far we get. Looks good. Let's see here. Running, I'm behind. Okay, that looks good. Looks pretty good. Going up here. Also good. It's actually working great. And that's kind of the problem.
Huh?
Because when I was planning this episode, there was a bug here that drove me nuts. Because it was flickering back and forth. The position of the player was jumping from one frame to the other over and over, back and forth. And that is because right here, when we compare it, we're using hitbox on top. Yeah, that makes sense. But what if a game object or a skeleton is comparing itself with the player? Then the player will be this other one, and other.hitbox.top. And that would give a false result. So what we need to do is to use the same minus other.last camera value or Y value, just to make sure we don't get that bug. I hope I can show a video of it. But it doesn't exist in the entity class. So we're gonna move this one into the entity class like that. From player, we're gonna take this one. We can place it like so and take it together. Place it here. Take this last and place it up here. So now we have this last camera Y value and last camera Y value in the entity class, but we're only going to use it for the player. But that's just to make sure that sometimes this part is going to be the player entity, sometimes this is going to be the player entity, just to make sure that we don't get any type of weird visual bugs. So it should still work the same. And now the visual bug obviously doesn't show up, but we made sure that it can't show up. So this is looking good. Player behind, player in front, player behind, in front. And the reason why we are still kinda on top of the objects or houses or wherever we are, is because it's using the top line and comparing it with the top line of the player. And as soon as the player's Y is less than the object, we are now in front of the object. But that is something we're gonna solve in the next episode, where we put a hitbox on each object to not allow the player to go through it, first of all, but also so it looks more like there's more depth to our game. And that, my friends, is the first episode of the year completed. Our painter's algorithm is working great. Now we just need to tweak it to make it look even better. That's for the next episode though. So thank you guys for watching, take care and have a wonderful day. Cheers!